The motherboard, the heart of a computer system. In the world of technology, the motherboard is often referred to as the heart of a computer system. Just as the heart pumps blood to keep the human body alive, the motherboard serves as the central hub that connects and powers all the essential components of a computer. Without it, a computer simply cannot function. This script will explore the critical role of the motherboard, its components, how it works, and why it is considered the backbone of any computing device. Introduction to the motherboard. The motherboard, also known as the main board or system board, is a large printed circuit board, PCB, that acts as the foundation of a computer. It is the primary platform where all the hardware components of a computer are connected. From the CPU and RAM to storage devices and peripherals, every part of the computer communicates through the motherboard. It ensures that all these components work together seamlessly to perform tasks efficiently. The motherboard is not just a physical connector, it also houses the firmware, BIOS, or UEFI, that initializes the hardware during the boot process and provides the necessary instructions for the operating system to take over. In essence, the motherboard is the glue that holds the entire computer system together. Key components of a motherboard. To understand the motherboard's importance, let's break down its key components and their functions. CPU socket, the central processing unit. CPU is the brain of the computer, and the CPU socket is where it is installed. The socket type determines which processors are compatible with the motherboard. Modern motherboards support CPUs from manufacturers like Intel and AMD, each requiring specific socket designs. RAM slots. Random access memory. RAM is where the computer stores data temporarily for quick access. The motherboard has dedicated slots for RAM modules, and the number of slots determines how much memory the system can support. Faster RAM and more slots can significantly improve a computer's performance. Expansion slots. Expansion slots, such as PCI Express PCIe slots, allow additional components like graphics cards, sound cards, and network cards to be installed. These slots enable users to upgrade their systems for better performance or additional functionality. Chipset. The chipset is a set of microchips on the motherboard that manages data flow between the CPU, RAM, storage, and other peripherals. It plays a crucial role in determining the motherboard's capabilities, such as the number of USB ports, SATA connectors, and support for overclocking. Storage connectors. Motherboards include connectors for storage devices like hard drives, HDDs, and solid-state drives, SSDs. Common connectors include SATA and M2 slots, which allow for high-speed data transfer between the storage device and the rest of the system. Power connectors. The motherboard receives power from the computer's power supply unit, PSU, through dedicated power connectors. These connectors ensure that the motherboard and its components receive the correct voltage and current to operate. BIOS Wi-Fi chip, the basic input-output system, BIOS, or Unified Extensible Firmware Interface, UEFI, is firmware stored on a chip on the motherboard. It initializes the hardware during startup and provides an interface for configuring system settings. I/O ports. The motherboard features a variety of input-output I/O ports on its rear panel, including USB ports, audio jacks, HDMI or DisplayPort for video output, Ethernet ports for networking, and more. These ports allow users to connect peripherals like keyboards, mice, monitors, and external storage devices. Heat sinks and VRM. Modern motherboards come equipped with heat sinks and voltage regulator modules, VRMs, to manage heat generated by the CPU and other components. Efficient cooling is essential to maintain system stability and prevent overheating. How the motherboard works. The motherboard's primary function is to facilitate communication between all the components of a computer. Here's a step-by-step overview of how it works. Power on. When you turn on the computer, the power supply unit sends electricity to the motherboard. The BIOS UEFI firmware initializes the hardware components and performs a power-on self-test to ensure everything is functioning correctly. CPU activation. The CPU seated in its socket begins executing instructions from the BIOS UEFI. It coordinates with the chipset to manage data flow between the RAM, storage, and other peripherals. Data transfer. Data travels between components through the motherboard's circuitry. For example, when you open a program, the CPU retrieves the necessary data from the storage device, processes it, and stores temporary information in the RAM.